I wear the beast, Skyline, quick speed. Hot young said cash for increase. I saw it with fans paying on me. And anything the gang start complete. It complete, accomplish. I'm a day in the game, I'm a day self-esteem. I'm not gonna wait out. Some stop my name.
Oi, 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 we're back, we're back, we're back, we're back. Oi, 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 we're back, we're back, we're back, we're back. I need to find my fucking match. What's great? No, 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 no. Oh yeah, oh yeah. Okay, so first of all, we're going to do some stuff. This. So as it's calculate things how I know. Design just up. Like design top. No. So I thought we got one. Okay, so as I say, today is कति June 30 है आज के आने आंदा रही है about this unit. Let's go. First of all, यो सबै आउनु पर्ने है मलाई चाहिँ. I should know सबै. Let's start. अहिले यो सकाउँछु. Firstमा चाहिँ goal चाहिँ भयो. First we'll just try to complete all of these. And second time we'll just know it. First my area and volume है. First my area and volume. Volume of problem goal rank is easy. And then volume of a cone. Uh,
Let's think a little bit about the volume of a cone. So a cone would have a circular base, or I guess it depends on how you want to draw it. If you think of like a conical hat of some kind, it would have a circle as a base, and it would come to some point. So it looks something like that. This geometry is that it's not as this is 1/3 times pi, or pi over 3 times h r squared, however you want to view it. The easy way I remember it, for me, the volume of a cylinder is very intuitive. You take the area of the base and then you multiply that times the height. And so the volume of a cone is just 1/3 of that. It's just 1/3 the volume of the bounding cylinder is one way to think about it. But let's just apply these numbers just to make sure that it makes sense to us. So let's say that this is some type of a conical glass, the type that you might see at the water cooler. And let's say that we're told that it holds, so this thing holds 131 cubic centimeters of water. And let's say that we're also told that its height, right over here. I'm going to do that in a different color. We're told that the height of this cone.
okay, volume of a cone is pi square h. Okay, 1 pi square h. Okay. Okay, so right so so volume of a rectangular prism is length with height. Volume of a cylinder is pi square h. Okay, pi square h. Okay, 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 I'm not too many of these, right? How
So I have a rectangular
changes, how volume dimensions.
prism here, and we're given two of the dimensions. The width is 2, the depth is 3, and this height here we're just representing with an h. And what we're going to do in this video is think about how does the volume of this rectangular prism change as we change the height. So let's make a little table here. So let me make my table. So
This is, if it increases the height, the volume decreases.
let's think about something interesting. Let's think about what happens if we double two of the dimensions. So let's say, so we know, I'll just draw these really fast. We know that if we have a situation where we have 2 by 3 and this height is 5, we know the volume here is 30 cubic units. But now let's double two of the dimensions. Let's make this into a 10 and let's make this into a 4. So it's going to look like this. And then this is going to be a 4. This,
And it's going to 4x, the volume is going to 4x.
think about why did that happen? Well, if you double,
That's just,
what I want to do in this video is think about how does the circumference and how does the area of a circle change as we change its radius. In particular, that's my best attempt at freehand drawing a circle. So let's just think about
but it's just gonna be squared. What? Alright, so who's under A as a follower 60. Okay. Aspire square it's right, this is wrong. This is a good answer. Just doing so. Okay. There you go. Two, right? We got you want the three. Okay, man. 4 by 3. Right rectangular prism that is a line. Okay, I don't know the formula. It's LWS. Okay, fuck. I know the formula. It's 1 by 3 pi r square. It's right. It's no, it's pi r square. It's pi r square. It's easy. It's pi r square h is equal to that 144 by 9 is equals to r is equals to root answer is equal to 4 times 2 is 8. And this is dumb.
A tea infuser in the shape of a
Okay, we have volume of a right rectangular pyramid. So it's 1 by 3 into 7 by 9 into 3 into 1.5, right? Right. Now we got 80%. Now answer 80% of answer. 9.48 is B.
right rectangular 5 times 7.9 centimeters cubed, or cubed, we get 9.48. 9.48. And if we round to the nearest tenth, well, the round to the nearest tenth, we have an 8 in the hundredths place. We're going to round up to 9.5, which is exactly.
Do I take 5 minutes? What? Okay, I have volume writing. Here's 4 cubic meters, right? We have 4 right circular cone. What's the volume of right circular cone? Right circular cone is 1 by 3 pi r square. It's 1 by 3 pi r square. It's pi r square. It's right. So is equals to 4. So we have 1 by 3 times pi 2.5 times the radius, right? So you got 7h times 2 to the 4 r square. 2.5. Wait, what's the square of 2.5? 2.5 squared. That's 6.25. It's 6.25 r squared. So we got 7 times 6.25. We got 43.75, right? We got 43.75. 5 times 4. The answer is 175. C is the right answer. Okay, this was easy. Okay, which was volume of spheres. Okay. The one. Let's see. See. I'm so dumb. K pi is equals to 4 by 3 pi times 3 cubed. Pi 4 times 3 square means 3 is 9, 9 times 4 is 36. 4 times 36. Very good. Ah, wait, what? Wait, my calculator didn't register. Okay, that's not my fault. That's not my fault. Oh, it's my fault, yeah. I've gotten sloppy. I got gotten like sloppy. I think the advanced section was just new stuff. This is defense. These are some questions. This used to be a simply 9.
We're given a bunch of lines here that intersect in all different ways and form triangles. And what I want
Wait, this is taught to my little fucking sister. What is
to do in this video, we've been given the measures of some of the angles, this angle, and that angle. And what we want to do in this video is figure out what the measure of this angle is. And we're going to call that measure x. And so I encourage you to pause the video right now and try it yourself. And then I'm going to give you the solution. So I'm assuming you've unpaused it and you've solved it.
So to find the value of x, this is easy. This is very easy. Because this is equal to this, and it's x is equal to. I can do the fucking math. What? X is equal to 49, right? What's on 80 minus 121? 59. Okay, the answer is 59, right?
That we have in this triangle right over here. We have a 92 degree angle. 21 is going to be 29 plus 9, which is going to be 92. And so that is going to equal 180 degrees. And so x is ways, the ton of ways.
Okay, this is fucking hell. It is just dumb, okay? 60. Okay, good. What is this? 105? Yeah, it's 105. And then A. Fuck you. I'm not doing this. A is A with what is A? What is A? A is 73. I'm not doing it.
In this first problem over here, we're asked to find out the length of this segment CE, and we have these two parallel lines, AB is parallel to DE, and then we have these two essentially transversals that form these two triangles. So let's see what we can do here. So the first thing that might jump out at you is that this angle and this angle are vertical angles, so they're going to be congruent. The other thing that might jump out at you is that angle CDE angle CDE is an alternate interior angle with CBA. So we have this transversal right over here, and these are alternate interior angles, and they are going to be congruent. Or you could say that if you continue this transversal, you would have a corresponding angle with CDE right up here, and that this one's just vertical. Either way, this angle and this angle are going to be congruent. So we've established that we have two triangles, and they have two of the corresponding angles are the same, and that by itself is enough to establish similarity. We actually could show that this angle and this angle are also congruent by alternate interior angles, but we don't have to. So we already know that they are similar. Actually, we could just say it just by alternate interior angles. These are also going to be congruent, but we already know enough to say that they are similar even before doing that. So we already know that triangle. I'll try to write it, I'll color code it so that we have the same corresponding vertices. And that's really important to know what angles and what sides correspond to what sides so that you don't mess up your ratios, or so that you do know what's corresponding to what. So we know triangle ABC is similar to triangle. So this vertex A corresponds to vertex E over here, is similar to vertex E, and then vertex B right over here corresponds to vertex D, EDC. Now, what does that do for us? Well, that tells us that the ratio of corresponding sides are going to have the same, they're going to be the same. They're going to be some constant value. So we have corresponding side, so the ratio, for example, the corresponding side for BC is going to be DC. We can see it just with the way that we've written down the similarity. If this is true, then BC is the corresponding side to DC. So we know that BC, the length of BC over DC, right over here, over DC, is going to be equal to the length of, well, we want to figure out what CE is. That's what we care about. And I'm using BC and DC because we know those values. So BC over DC is going to be equal to what's the corresponding side to CE? CE, the corresponding side over here is CA, is going to be equal to CA over CE. CA over CE. Corresponding sides. This is the last and the first, last and the first. CA over CE. And we know what BC is. BC right over here is 5. We know what DC is. It is 3. We know what CA or AC is right over here. CA is 4. And now we can just solve for CE. So we can, well, there's multiple ways that you could think about this. You could cross multiply, and you get, which is really just multiplying both sides by both denominators. So you get 5 times the length of CE. 5 times the length of CE is equal to 3 times 4, which is just going to be equal to 12. And then we get CE. CE is equal to 12 over 5. It's equal to 12 over 5, which is the same thing as 2 and 2/5. 2 and 2/5, or 2.4. So this is going to be 2 and 2/5. And we're done. We're able to use similarity to figure out this side, just knowing that the ratio between the corresponding sides are going to be the same. Now, let's do this problem right over here. Let's do this one.
And then do the problem right over here. So first of all, we have angle. We have this. We need to make this. So what I did was angle CBD, and angle A. Yeah, try to find. Okay, so we have this angle. We go to this angle, and this angle equals to this angle, and this angle is the same, right? So we have first of all we have B A. Okay, we have CBD. I don't understand. Yeah. So we have BA, right? So we have BA. Yeah. We have CBD and angle triangle. CBD and CAE. So we go 5, 4, 3, right? So this, right? So you know that CB by CA, CB by BA is equals to DD by DB, right? Just financial features where D is equals to CD times CD times DB. So by 5 also.
DE. This part right over here, they're asking for DE. So we know that this entire length, CE right over here, this is 6 and 2/5. And so DE, right over here, what we actually have to figure out, it's going to be this entire length, 6 and 2/5, minus 4, minus CD right over here. So it's going to be 2, 2 and 2/5. Entire length, 6 and 2/5, minus 4, minus CD right over here. So it's going to be 2, 2 and 2/5. 6 and 2/5 minus 4 and 2/5 is 2 and 2/5. So we're done. DE is
Right. Yeah. Mm. This is boring. Yeah, I understand this.
In the diagram,
Okay. If I can do this, I'm gonna do it. I'm gonna do this, I'm gonna do it right. So if AD, let's say if AD, okay, so that those angles are similar, right? So we have two triangles. Oh, we have CD and we have AB. I actually don't know what to study right now, but I am going to this. I have to fucking okay. So we have this angle equals to this angle. We have this angle equals to this angle, and we have this angle equals to this angle. So we have triangle ABC. And triangle ABC is equals to triangle D ABC, the DEC. There you go. What's the length of side CE? What's the length of side CE? Okay, CE. What's CE is equals to BC, right? CE by BC. CE equals to KBC. Okay, CE by BC. CE is equals to KBC, right? Then C. And we have AC is equals to KCD. Okay, so we have AC by CD. But we don't have those, right? CE, right? AC by CD, no, it will be A. Okay, no, it will be A by DE equals to CE by BC. BA by DA, BA 0.5 by DA, BA by DA times BC. So this is 0.7.
diagram at left. Well, multiple ways to solve this, but one way we could get 6.3. And if we look down here, we see that
Okay, I got it completely wrong. What? How did I get it wrong? Okay, CE, right? Good. BC is equals to KCE, right? DE by BA, CE by BC. So CE is E by BA, BE is 7.3 by BA times BC. 6.3, right?
side C is a angle. Right? Base to solve 5. So this is going to be, what is that, 6.3. And if we look down here,
Okay, no, I didn't do it wrong. Yeah, I did it wrong for the question. I should be able to do this. Yeah, I understand. Assignment. ABC is isosceles. ABC is isosceles. That is maybe equals to BC. Okay, so this is very easy. This is very easy. So we have that angle is equals to 40. Thus, that angle equals to 80. So P is equals to 80.
To 80 degrees. So what is the value of P? Or I guess this is P degrees. So the value of P is 80.
Okay, it was easy. This is so dumb. Lesson 3. What are right angles trigonometric problems? How do about understanding the relationship between blah 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 blah. This is easy. This is easy. This is easy. Okay, this I don't know. Okay,
And this
okay, I know that. I know this. Okay, this is dumb. What is the length of BE? The length of BE is 5 foot 3. So if CD is equals to 6, what's the length of AC? If CD equals to 6, right? CD is equals to 6. So if CD equals, this is actually a decent question. Well, that's fine. Wait, I don't know. I don't know how to do this question. B is equal to 3, right? So we have root under 5 square minus 4 square. 3, right? So 3, K is equals to 2, right? So if K is equals to 2, that means we have those similar angles, right? Similar angles, then AE is equals to ED. Is ED equal to 8? Does ED equal to 8? So ED should equal to 8, right? So ED equals to 8. That means 6, 8. Root under 6 square plus 8 square. But it's done. What? It does not add up at all. So why would this angle and this angle are the same, right? So AB is equals to KBC. So we have BC is equals to KAB, and then we have CD is equals to KBE. CD by BE is equals to BC by AB. Now we have BC equals to CD. CD is 6 by BE. BE is 3 times AB. AB is 5. So so CV is 10. The answer 15. That's 15. Let's check. Okay, I got it wrong. So is this the correct answer? Wait, I had got it wrong, correct already. Like, what? Yeah, yeah.
we've got
Okay,
two right.
I've actually, okay, let me see if I can remember the quote he said. It's like sine cicatura. It was two, right? Yeah. Yeah, it was something like sine catua or something. That was cool. It was cool. It was a cool way to memorize. Uh, what sine and cosine. It's so katua. Yes, it's so katua. It's opposite side and that's heavily used, right? It's so katua and what's the opposite? It's easy. No, it's so katua. It's so katua.
Triangles here. Let's say the length of segment ED. Or we could also write that the length of segment AC, so AC over the hypotenuse, over this triangle's hypotenuse, over AB, is equal to DF over DE. Once again, this green side over the orange side. These are similar triangles.
So katua. Yeah, what is it called? 3 by 5, right? It's 3 by 5. DEF. DEF. F. And F and F. ED by DF. ED by DF. Wait, but how am I supposed to know? What the fuck? Wait, I'm supposed to find out the value of the ED and D. It's 4 by 3. That's because it's multiplied by K, right? Okay, what? Could have 90 and just okay, so 60, 20, 30. 6, 3, 6, 9 triangle. Let's have as it was. Okay, sine A is equal to Aya fuck. This is so hard. What? Kusto aapte hi gamelo. Sine A is 1 by 2, right? Sine A is 1 by 2. So sine A is 1 by 2. Sine A is 5 by AC. 5 by AC is equals to 1 by 2. AC is equals to 10. A measure of angle C. Wait, what's the measure of angle C? Okay, like I can do this, right? Because we know that set sine 1 by 2. 30 at 60, 30. This is 60, 30, 60.
We see in a triangle, or I guess we know in a triangle, there's 3 angles. And if we're talking about a right triangle, like the one that I've drawn here, one of them is going to be a right angle. And so we have 2 other angles to deal with. And what I want to explore in this video is the relationship between the sine of one of these angles and the cosine of the other, the cosine of one of these angles and the sine of the other. So to do that, let's just say that this angle, I guess we could call it angle A, let's say it's equal to theta. If this is equal to theta, if its measure is equal to theta degrees, say, what is the measure of angle B going to be? Well, the thing that will jump out at you, and we've looked at this in other problems, is the sum of the angles of a triangle are going to be 180 degrees, and this one right over here, it's a right triangle. So this right angle takes up 90 of those 180 degrees, so you have 90 degrees left. So these two are going to have to add up to 90 degrees. This one and this one, angle A and angle B, are going to be complements of each other. They're going to be complementary. Or another way of thinking about it is B could be written as 90 minus theta. If you add theta to 90 minus theta, you're going to get, or theta to 90 degrees minus theta, you're going to get 90 degrees. Now, why is this interesting? Well, let's think about what the sine let's think about what the sine of theta is equal to. Sine is opposite over hypotenuse. The opposite side is BC. So this is going to be the length of BC over the hypotenuse. The hypotenuse is side AB. So the length of BC over the length of AB, over the length of AB. Now, what is that ratio if we were to look at this angle right over here? Well, for angle B, BC is the adjacent side, and AB is the hypotenuse. From angle B's perspective, this is the adjacent over the hypotenuse. Now, what trig ratio is adjacent over hypotenuse? Well, that's cosine. So COT, let me write that down. Sine doesn't hurt. Sine is opposite over hypotenuse. We see that right over there. Cosine is adjacent over hypotenuse, ka, and toa, tangent is opposite over adjacent. So from this angle's perspective, taking the length of BC, which is BC is its adjacent side, and the hypotenuse is still AB. So from this angle's perspective, this is adjacent over hypotenuse. Or another way to think about it is the cosine of this angle. So that's going to be equal to the cosine of 90 degrees minus theta. That's a pretty neat relationship. The sine of an angle is equal to the cosine of its complement. So one way to think about it, the sine of, we could just pick any arbitrary angle. Let's say the sine of 60 degrees is going to be equal to the cosine of what? And I encourage you to pause the video and think about it. What's going to be the cosine of 90 minus 60? It's going to be the cosine of 30 degrees. 30 plus 60 is 90. And of course, you could go the other way around. We could think about the cosine of theta. The cosine of theta is going to be equal to the adjacent side to theta, to angle A, I should say. And so the adjacent side is right over here. That's AC. So it's going to be AC over the hypotenuse, adjacent over hypotenuse. The hypotenuse is AB. But what is this ratio from angle B's point of view? Well, the sine of angle B is going to be its opposite side, AC over the hypotenuse, AB. So this right over here, from angle B's perspective, this is angle B's sine. So this is equal to the sine of 90 minus 90 degrees minus theta. So the cosine of an angle is equal to the sine of its complement. The sine of an angle is equal to the cosine of its complement.
No. This is boring. This is literally like boring. Wait, what? Wait, why did these two switch places? Like, I didn't mean to do that. I didn't need to fix it. BD is valid to E. What is the length of DE? What? So BD is valid to AE. Right? So BD is valid to AE. So BD. Okay. What's about DE? So what is CD? That's the question. So CD is root 8 square of 6 square. 10. Oh, that's 10, right? Now the other triangle will be 12 by 8 times 10 to 15. So it's 5. What's the value of sine f? So sine f sine f is equal to sine c. Sine c is equals to opposite 7 by 25, right? So then the PC is equal to, okay, so the R sine c is equals to 3 by 5, because this is equals to opposite side 3 over 5. Isn't this dumb, bro? Like, that's equal to 3 root 34. So it's root 34. How am I supposed to write root 34? Okay. Alright. 3 by 5, right? 3 by 5. That's 5 root 34. How do you write 5 root 34? 5 and 34 the power 1 by 2. Okay. How am I supposed to do this? How am I going to write 5 root 34? 29.15. 29.15. Wait, how am I supposed to write that? It's 5 root 34. That's 5 root 34. What? Oh, it's completely wrong, yeah. I'm an ass at maths. Really good. I am ass at maths, bro. BD is equals to root under 15 square plus 9 square. If you do 24, right? That is equals to that. No, 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 no. No, 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 no. Okay, do I really want to do this? Yes, right. So fuck. How am I supposed to do this? What? So you see, this is 3 by 5, right? Sorry, so it's equals to 3 by 5. Now sine C is equals to BD by DC. Oh, am I dumb? Wait. Sine C is equals to BD by BC. Sine C is equals to BD by BC. Okay, 3 by 5 is equals to BD by BC. BC is equals to BD times 5 by 3. It's 5 to 34. Yeah, exactly. I How is BD equals to 12? Like what? Root 15 square plus 9 square. Okay. Let's not talk about it. It's 12. Let's not fucking talk about that. It's 12, right? So we have 12. Okay, let's not fucking talk about it. If AD is rather to BC, and CD is equals to root 2 AB, which is the measure of the angle C. What? How am I supposed to know? Because I guess we draw something nice. Da, da, da. That's 90 there. So we have CD is equals to, okay, that's it equals to that. Where's the measure of angle C? Because it's easy. Never mind, it was easy. Angle C, right? So angle C will be equals to sine C. Okay, we have sine C is equals to, no, it's cos C. Yes, cos C is equals to AB by root 2 AB. So 1 by root 2. So we have shift cos 1 by root 2. 45 is the right answer. Wait, what? Angle C. Wait, there's no way I got it wrong. Hmm? It's equal to A, right? So it's a measure of angle C. Yeah, it's CD is equals to root 2 AB, right? CD is equals to root 2 AB. Exactly. I did AB by root 2 AB. This is CD is hypothetic. So CD. Oh, my bad. My bad. I should have taken D instead. Yo, actually, this is hard. Okay, first of all, 45 looks wrong. Okay, 45 looks wrong. 45 is already wrong. I don't know what the fuck I was thinking. Right. So it's if D is 45, then the answer is 135. Okay, I don't know why. Okay, I'm done. I'm done. I'm done. Okay, why did I choose angle C to be 45? That's angle D, exactly. need the water. Exactly. I've been growing like dumb by everything.
In the figure above, triangle LM.
Tan R is 4 by 3.
In triangle A.
Angle ABC above FE is equals to BC. That means it's 34. The sine angle ACBD. Angle CBD. What's the sign of angle CBD? What's the value sign of? What's the sign of CBD? Okay, let's find out. Right. So it's 34, 34. That means that angle is. Okay, this is a third question to solve. Yeah. Alright, let me get back to the Okay, I'm solving right now. BD CA, right? It's 34. It's 34 as well. That means this whole angle is what's 180 minus 34 times 2? 34 times 2 is 112. Answer by 2 is 56, 56, 56, 56. So we got 56, 56. Okay, so we have 56, 56, and we got 90, 90, right? 34 is 56, plus 34 is 90. Okay, now this is easy, right? So, let's find angle of value of angle CBD, sine CBD. So sine CBD, sine CBD, sine 56 is equals to well opposite angle CD by BC, and then we have sine we have cos angle BAC, right? Cos angle BAC. So what cos of angle? Okay, so cos of angle BAC, BAC is 34, and that equals to 80 by BAB, right? So we have sine 56, sine 56, we have sine 56 minus cos of sine 56 minus cos of 34. Cos 34 is sine 90 is sine 56 minus sine 90 minus theta 34. 56, right? 90 minus 34. 34 is 56, so it's 0 is the right answer.
AB. Quite clear. This is AD over AB minus AD over AB, which is going to be equal to 0. And we're done. In triangle ABC above, AB is.
Yay, we're done. There you go. What's the cos of angle ABC? Cos of angle ABC as ABC is 5 by root 61. 5 by root 61. This is the correct answer. Right, so AC is equal to 5, the length of BC is equal to 7, so the length of AB. So root 7 squared plus 5 squared. We have B is the right answer. Triangle ABC. So much angle ABC. So B, right? So we have 3 by 3 means 1 by root 2 or root 2 by 2. What's an angle length of AB? Isn't this the same question they've asked? It's definitely 65, right? Let's go, quiz 1. Boom. They say it's gonna take like 5 minutes or some shit. That's definitely not right. 7 by 85. 7s. Meow, 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 meow. Pi times r squared, 12 squared, and 2. It's not gonna take 5 minutes. What do you mean? Like, it's just easy, right? This is like easy. It's 5 times 3 times 4. 60. It's 56. How much time did it take? I don't know. Okay, what are circle theorems? Fuck. Okay.
I have a circle
Okay, I'm just bored. We'll complete this, yeah, we'll complete this. Don't worry, don't worry. We'll complete lesson 5 and then we'll try to stream some stuff as well. Okay, I'll try to stream me learning. But is it okay if I stream me learning some effects in DaVinci Resolve? I guess. I guess that works too, right? So we have a 50-minute stream right here. Wait, so how much time did I take? Wait, what? So I started the quiz. Wait. Okay, so I um started the quiz at 1:28. 1:28 and I was done by okay, it took me a minute. Okay, that's cool, I guess. Circle theorems. Arc length, sector, areas, and angles in circles. This is easy.
here
The
whose
arc length
circumference is
is S equal to R theta, right? This is easy. Area sector is equals to,
a
I
circle with
know.
area 81 pi, has a sector with a 350-degree central angle. So this whole sector right over here that's shaded in this kind of pale orange yellowish color, that has a 350-degree central angle. So you see the central angle is a very large angle. It's going all the way around like that. And they ask us, what is the area of the sector? The ratio between the area 81 pi, the total number of, this is the central angle over the total degrees
But area sector by 81 pi is equal to
in a circle. And then we just can solve for area of a sector by multiplying both sides by 81 pi. 81 pi, 85 times 36, 35 minus 15.
Give me a
Did I do that right?
formula. Formulate for calculating the area of the area of sector of a circle. Okay, it's theta by 360 times pi squared. Okay, theta by 360 times pi squared. There you go. It's that easy. So you got theta. Theta is 350 by 360 times pi r squared. So we got what's pi r squared? What the fuck? Pi times 81 pi squared. That's the radius, right? So let's see if we get the same answer. Theta by 360 times pi squared. Pi times 81 which is pi whole square. So we get the correct answer?
Over 4. 315 pi over 4 is the area of the sector.
That's 315 pi over 4. Like what? 315 pi minus 315 is pi over 4. Okay, what the fuck? There has to be a formula.
It's 18 pi. So if we pi over 36, which is the same thing as pi
Arc
over
length
2.
by
So this arc right
circumference.
over here is going to be pi over 2, whatever units we're talking about, long. Now let's think about another scenario. Let's imagine another, or the same circle. So it's the same circle here. Our circumference is still 18 pi. So circumference is still 18 pi. There are people having a conference behind me or something. That's why you might hear those mumbling voices. But this circumference is also 18 pi. So this is also 18.
So we got arc length by circumference. Okay, it's just similarities. Okay, we're just utilizing the foundations of the topics that we learned right before coming to this, I guess, topic, right? We're just using the basics. Because do the basics then. So it's that by that is equal to that by that. Okay, so here the area of a sector.
A circle
Okay, so the area of a sector here will be equals to area of sector divided by area of circle will be equal to uh wait, you just chant the formula like that. Area of sector divided by area of circle. Right? Area of sector divided by area of circle is equals to area of circle plus square. There you go. It's the basics. The formula is the basics. Radio sector by 81. Hey, why are we using uh hockey? Okay, this is dumb. So consider the
What is the
length.
length of arc AB?
What is the length of RKBC? R theta. So we just do convert 135 to radians and then we just do it. But here we're just gonna do use the dumb way, right? Dumb way, or maybe it's the smarter way. So here we're just gonna be doing arc length. We're doing 135 by 360 times pi r 2 pi r. So we'll do 2 pi times 3. So it's equal to 9 by 4 pi. So what's it? It's gonna be 9 by 4 pi, right?
By 3 fourths times pi.
Yes, so it's gonna be 9 by 4 times. So I guess, yeah, this is an easier question, easier way to solve this question. Especially when you don't know how to convert degrees or radius. But I find the way that that way to find these this arc length, like I'm using the degrees to radians and then also using the formula as with r theta, more convenient because it's more reliable. I don't need to be writing lots and lots and lots of ratios and then equating them just to find the length of a radius, length of an arc of circle, like what that's scoring. And then here too, right? The intercircumference test, and then just add this like that. Oh, so length of x. So there you go. Like this is dumb, right? This is the sum. An arc x. Now this is the same thing. So we got 260. Let's do 260 by 260 times 10 pi. Now this answer is 65. This answer is C. Right?
And it looks like that's about as simplified as I'm going to get. And that's nice because that's one of the choices.
Answer is C. Like this is easy. Yeah, this is easy. Fuck. Wait. So now I'll just be right back. I'm back. I'm back. Hmm. More blocks. Really? You know what? How am I supposed to do this? I don't know how to solve this question at all. I have no idea. I have no idea. What? No, then the first question that I had zero idea on how to do any question.
I'm not wearing a fucking suit to go bowling.
Well, I'm not going bowling unless you.
Okay, I have zero idea on how to do this question at all. I have no idea on how to do this question. So, first of all, okay, let's just not see the answer, and to just try to solve ourselves, right? That's the first thing I'm gonna do. We have this. We have this, right? So we have this. So wait, I don't need this. I don't need this. So I just need this, right? These are the two questions that I. No, I just want right. We have this. In the figure above, O is the center of angle AOB is pi by 6 radians. So we have 30 degrees, right? Actual 3. Remember OA is 2 to 3. We have OA. That's 2 to 3, right? We have pi by 6. So can we just take this as a straight line? If I can take that as a straight line, then I'm all good. There is no way I can take that as a straight line at all. Okay, so we'll have to do this. I have 30, 60. So I have 60, we have 30. 30, 60. That's 2 to 3. So that's 2 to 3. Here's 2 to 3, right? 2 to 3, then it's 2, and then this is 4. Right? This is 2. Oh, the y coordinate is 2. The radius of a circle will be 4. So I need to memorize this. Okay, so I need to memorize this. Okay, there you go. I'm not completely clueless. I must have this. Wait, I already given this. Oh, yeah. Yeah. So we got action 3, x 2, x, right? So in the other one, it's x, and action 2, right? Okay, yeah. Okay, yes, okay, so I have a decent idea now.
What I have attempted to draw, it has the coordinates a, comma, b. The x value where it intersects is a. The y value height right over here is going to be equal to b. The y coordinate right over here is b.
This is just boring. What?
On the right-hand side, we have a bunch of expressions that are just ratios of different information given in these two diagrams. And then over here on the left, we have the sine taken of angle MKJ, cosine of angle MKJ, and tangent of angle MKJ. And angle MKJ is this angle right over here, same thing as theta. So these two angles have the same measure. We see that right over there. And what we want to do is figure out which of these expressions are equivalent to which of these expressions right over here. And so I encourage you to pause the video and try to work this through on your own.
Sine angle MKZ. So we got MKZ. Sine of angle MKZ will be K by M. We have K by M, yes, K by M. The cos of angle MKZ, it will be Z by M. Tan of MKZ will be K by Z.
So circle definition of x over 1. Angle theta, that is the adjacent side.
Okay, this is dogwood. Is measures value of A. So we have 80 pi. So 135. Right. A is a constant. So we have 8 pi. 135. So you got 180 by 135. So we have 180 by 135 as our area, right? So uh, oh, okay, so we have 180 is equals to 1 radian, that means the 1 by 180. Okay, so we that's pi is equals to 180 degrees, right? So pi is equals to 180 degrees, so pi by 135. Pi by 180 is equals to pi by 180 times 180, 135, yes. So we got 6.3 equals to pi by 180 times 135. So we got okay, fine. What is 135 by 180? 3 by 4. 3 by 4, right? 3 by 4 is the answer. 3 by 4. So what's it? 5. Yeah. There you go. Okay, we just had a circle. The measure of angle AOB is x by a. What's the value of a? AOB is, I guess it's root 3. So it's 1. Root 3 is 1. What's the value of a? What is it? Oh my god, this is odd. What the fuck is this? X by a. So, what's root 3? Root 3, root 3, root 3, root 3, root 3. So that. After that, then I don't know. It's one has it's one. It's one. It's root 3. So it's one. It's root 3. Oh, it's one. It's root 3. So it's angle AOB. So tan that is equals to root 3 by 1. It's root 3. It's if tan root 3 in radian would be a 1 by 3 pi. So it's 1 by 3. That's 3 is the right answer. Right. Okay. I mean, go to work.
In the figure
Wait, where's my thing? The thing. Okay, I'm confused now. Wait, where's my thing? Where did my left side stuff go? Wait, how do I bring it back? Wait, how do I bring it back? I need this. Yes, this, exactly. So we have this. Yeah, 6. That's the same idea. Wait, I'm not ready yet.
in the figure at left, I put basic
I am not ready yet. So the missing sector of circus, that's what's the length of arc.
up here. Point O, point O.
Length of arc ACB. What's the length of arc ACB? Okay. The figure at left. We're going to the center of circle. The center of radius is the missing center of circle is the central angle. This. What's the length of ACB? Okay, this is just easy. So we have what to do here is firstly we find the sector AB. That's false. Okay, so what we do is we do 2 pi minus 2 pi minus 2 pi by 3. 2 pi by 3. Right, so we got 4 pi by 3. So what we do is 4 pi by 3 answer by 2 pi times let's do 1.5 by 2 pi r. 2 times if pi times 1.5. There we go. We get the answer as 2 pi.
is the center of a circle of radius 1. 4 pi divided by 2 is equal to 2 pi. So that's the length. That's the length of this arc. So it's
There you go.
in the xy
And actually, is the center of the circle. The fundamental of angle AOB is 5 pi by 6. So if the radius of the circle is 6, what is the y coordinate of point E? If the radius of the circle is 6. Okay, if the radius of the circle is 0, it's a y coordinate of point E. So it's 6, right? It's that, or 6 till there, it's 6 till there. Okay. Okay, so angle AOB, we are given the angle AOB. Okay, we're giving that angle. So we have that angle, yes, we have pi d, almost pi d. So we have 1 pi by 6, right? 1 pi by 6 is there. Well, we got 1 by 6 pi. Yeah, right. So it's a y coordinate of point E. How the fuck am I supposed to find this now? Meow, 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 meow. So that's 1 by 6 pi, right? 1 by 6 pi, yeah. So we are going 1 by 6 pi there. So 1 by 6 pi is equals to 1 by 6 times 360. 180. That's 30, yeah. That's 60, 30. So we got 2x, right? So we got a radius of the is 6. So we have x coordinate is 6. No, that's false. We got y coordinate. It's absolutely hard. It's so hard. No, do it that way. Yeah, make it that. Absolutely can. Let's go 1/6 pi. So we got 1/6 pi, right? 1/6 pi. We got 1/6 pi. 1/6 to 180. 7 is 30. We have 60. So we got 60 as pi. So 60 is 180 by 180 by 60 is 60 180. You got 1/3 pi, right? So you got 1/3 pi there. So 1/3 pi there. And it's 6. You got 1/3 pi there. And it's 6. So that, right? So it's 1/3 pi. So it's 1/3 pi is 60. 60, 30 in that, right? So we got 6. We'll go up to 6 there. So yeah, going up to somewhere there, right? So we got 6. What's the fucking point of that 6? Oh yeah, so the point of the 6. Okay, we got 6, right? So which one of it is a double? Yes, that's double, right? That's 6. That's 3. 3, right? 6. That's 3. That's 3 is the right answer, right? That's 3 is the right answer. Yeah, definitely that has to be it. That has to be it, right? So Windows C. No, Windows V. Hey, that has to be it. Wait. We got Discord, Windows V. So that has to be it, right? So it's 3, 3, right? So we got 3, right? That's 3. That's just right. That's 3. That's right. That's 3. 3 is a good answer.
What's going on? Because this is 1/2 the radius. That's what we need to figure out. The radius is 6. So 1/2 times 6 is equal to 3. And we're done. That is the y coordinate over here. It is 3.
Have the fucking code. Let's go. A pi is equals to that. Yeah. So 180 is equals to pi. 1 is equals to pi by 180. 8 times 1440. It's 8. 8. 6 times 180. 1080. The following radian measures is equals to. Wait, we just did. This actually for. Wait, this is not what I was taught in this lesson at all. Like we were taught like how to identify the special triangles. Hey, never mind. Wait. I just sent us 1800. Yes. Okay. So I got one left, right? Wait. There you go. So we got the last question, and then I'm done. Circle equations. Let's fucking go. I know all of this shit. You got x minus h whole square plus y minus k whole square is equal to r square. So this is dumb. It's going to use the center, and then we have got the equation too, right? So yes, yeah, the x square y squared plus 2 equal to f5 plus c. Now like completing the square system, brother. I'm not doing this. I'm not doing this. What do you mean? What's a standard circle? AC x squares. I'm just doing this to have
A circle in the
This is so we have I'll just find the fucking midpoints, right? So it's got 8 by 2 is 3 comma 5. So that's
a circle in
following an equation. So the center x minus s right? So x minus s. So we don't want to use use this point, right? We don't use this point. We don't use this point. So we use this point actually to find the radius, right? So we just find the radius. We got x minus x whole square plus y minus k whole square. So we got b, right? B and then this. So now for this, we need to find what do you call that? The radius, right? By the radius, we just use this formula. So it's equal to root under 25. So D is the right answer. And then I'm complete for today. That's it for today. What is the center and radius of the circle? Center is 3 minus 3, comma 4, and the radius is 7, yes. So this is the radius of the circle as root under 1.69 as 1.3. Probably 1.3, yes. I had to use the calculator to check, but I was pretty sure it's 1.3. So center and the diameter, we will follow the equation of the circle, right? So diameter is this r squared. Okay, so this is easy. This is very easy. So what we do here is x minus x whole square plus y minus k whole square, right? So it's between these, right? So we got diameter. So diameter will be 7 by 10, 0.7 by 2. And so whole square, we got 49 by 400. So we got this. Okay, so center C, positive point, P, and graph, blah, blah, blah. So for the solution to the graph of the circle, right? So you find the radius first. So radius is 1, 2, 3, 4, 5, 6, 7, and 8. The correct answer is 64. 8 is wrong. So we got y squared. Y minus 1 wrong. So we got 8 squared 64. Right. There you go. We got quiz 2, right? So we got quiz 2, and this I'll just do both of those off stream because I just don't want to stream right now. There you go. Thank you for